push that rock here with some math. I think we should do an example of a definite integral. So we have a definite integral here. We have an integrand, and we have what's called the limits of integration. This is the lower limit of integration. This is the upper limit of integration. There's a picture associated with this. If we go from 4 to 9, there's this function here is a curve up here. Let's see, if I put in 4, I get 1/2. Let's say that's a half. If I put in 9, I get a third. So a third would be maybe there. So it's coming down like so. And this would compute this area under here. So how do I do it? Well, the first thing I'm going to do is rewrite this as x to the negative 1/2 so I can use my power rule of integration. And my power rule of integration says add 1 to the power and get 1/2, and then I take the reciprocal of this and put it out front. And we have to remember that we're doing a definite integral, so we need to evaluate it at 4 and 9. So the standard notation is to draw a big vertical line here and put the limits of integration here to remind you to put the 9 in first. So we put in the 9, and we get, that's the square root of x, so the square root of 9, minus the function evaluated at 4, so the square root of 4. And to be safe, you ought to put brackets here because sometimes this is multi-terms and this negative distributes. But in this case, it's just one term. So anyway, I get 2 times 3 here, and minus 2 times 2. And so I have 6 minus 4, and the answer is 2. And that, ladies and gentlemen, is how you do a definite integral. Math made simple. Math.